All right. Yeah, thank you everyone for today's joining us for today's subseasonal forecast. Um, we've got over here at Rutgers, we've got Zach and Professor Decker. Michael is going to be our forecast leader today. And our special guest is Jason Lin, and I'm going to let Jason Lin here introduce himself in just a minute. But first, I want to turn it over to Michael to drive today's meeting.
Okay, so hello everyone. Just before we get really going here, just gonna go over. We've added a few more inputs since the last time I think you've been here, which I believe could be wrong, but I think it was a couple of months ago. So since then, Sandbox. We've added in some persistence forecasts, which haven't been doing particularly well. We've added in a persistence normal blend forecast, and we've added in some moving averages, 5, 10, 15, 20, and 30-year moving averages. And we've added in an MJO analog forecast, which was developed by Dr. Decker. So if you have any questions about any of those, just holler at us. So now to get into the meat and potatoes of things. So this is the most recently verified forecast. As you can see, everyone did particularly well except for the usual suspect, CFS, doing its usual CFS things. Does anyone have anything they want to say specifically about this forecast? Anything that verified anything that was particularly difficult?
I think she brought it up last week. It's the second week in a row that pretty much everybody did not go as warm as the verification did, which is interesting. I believe when we asked Shi about that, he said, I believe his answer was that climate change needs to really manifest itself in September. So it could be another week of that. I also had an idea, I don't know if it's true or not, but we had a lot of tropical activity in terms of some of the hurricanes and the tropical disturbances moving across the southeastern U.S., which could have brought a lot of warmth and moisture. So that's something that could have caused all of the forecasts to go warm. I'm not really sure how much that has to do with it, but it's just something quick little pattern that I noticed over the last couple of weeks.
Yeah, it's a good point about September. Just a quick note. I think Jason can obviously speak to this too. In terms of national CDDs, I think most of the forecasts now are on track for the warmest on record, at least since 1950. So yeah, this September is it's really coming in strong now.
Warmer than June.
Yeah.
September has eclipsed June.
Yeah, I think I was looking at the May to September period, just in general or overall, and I think it's on target to be the fourth warmest since 1950. So, and that factors in a relatively not hot start back in May. So we've really made up some ground here since July and August. Yeah, I don't know. Jason, do you have any, not put you on the spot, but I think that's a great question that was brought up. The fact that the last couple of weeks, the verification has come in above like everyone's expectations, everyone on this forecast contest. That includes some of the model guidance, the ECMWF, the CFS, some of our different averages, all the human forecasters, it's come in above it. Any thoughts in terms of what's driven this pattern and why, much of the guidance, it's coming in much or above much of the forecast guidance?
For this particular, mid to latter third of September, the things that jumped out at me were the rather pronounced positive EPO through this week, combined with the preceding week's really positive NAO. So while there has been a substantial amount of Western Pacific Eastern Pacific and Atlantic Basin tropical cyclone activity. And many of these cyclones have indeed recurved and integrated themselves into either the Pacific jet or the Atlantic jet. It seems that there hasn't been a whole lot of change in the eddy tilt, especially upstream over the Pacific. And really all these tropical cyclones have done is increase amplitude at times. And when you increase amplitude, you don't always have to do it in a way that brings cold. you can do it in a way that digs a pretty nasty trough through Alaska and through Greenland and go quite positive with those teleconnections. So I think there was some enhanced amplitude that was partially related to jet stream integration events with tropical cyclones. And I'm a pretty big believer in neighborhood sea surface temp anomalies. One major concern I had this summer for 2-meter temp anomalies to overperform, especially day 10 and beyond ensemble means, even out into the 16 to 20, is the very warm sea surface temperature anomalies that we have surrounding the U.S. Essentially, and I included this in some of my statements that for my forecast into the 16 to 20 for this round. If you're not drawing source region air from a northwest or northerly trajectory, you're pulling off a pretty warm, moist hot plate of a source region, be it from the Gulf, from the Caribbean, from the Southwest Atlantic Basin, and heck, even from the Eastern Pacific, west of the Baja and west of Mexico. Now, I know that probably doesn't get in at the 2-meter temp layer, but that elevated warmth aloft from 900 millibars up to 700, it moves the whole darn sounding to the right. Again, if you're not sourcing air off a northwest or northerly trajectory, I think ensemble means can have a hard time keeping up. So positive NAO, positive AO, neighborhood SSTs, I think all have contributed to outperformance to the warm side.
Thank you.
Can you pull up the 5-day mean 500 millibar heights or something like that for this period? Is that easy to do?
Did you hear that, Michael?
He said he wants the 5-day 500 millibar mean for this period.
Yeah, if you have like Dynacast open.
Yeah. So I think. Oops.
So it'd be like today the 24th, so like the 19th to the 23rd or something.
Not super good using this.
That's okay. Yeah. Products on the top right.
Okay.
Yeah, there you go, Dynacast. And then if you want to do the heights, so go under regions, one above that. Yeah, then go to like North America. Yeah, there you go. Yep. And then for parameter, I guess, see if there's like 500. Yep, exactly. Yep, you got it.
And then what days was this forecast? Oops.
Whoa. Yeah.
Raging positive EPO, trying to get some of the positive hive anomalies to come back westward towards Greenland, but not there yet. And this period and even a little bit after this period, the one thing that I've kind of noticed is the recurving tropical cyclones in the Western Atlantic Basin actually have contributed a little bit more to a negative tilt eddy structure across the Northern Atlantic, which is actually helping seed and drive the negative NAO projection a little deeper here in the 6 to 10, early 11 to 15 kind of period. But it hadn't got started yet, and this was coming off a week of really positive NAO to go along with that nice trough over the Bering Sea in Alaska.
And if you want, just before we move off attribution, maybe take a look at the SST anomalies too, since Jason brought that up. If you go to, I don't know if they have it. You can go to WX Prediction if if you want, I have a link there.
Assuming our no sandbox, I imagine, or is it resources?
No, just a separate link. Just open a different tab and just WX prediction. Different ways to get there, but this should work. And then under when you get there. Oh, so just WX prediction. Yep. All right, go to weather snapshot. I've got a few things here. If you scroll to the right, there should be an SST anomaly somewhere. There you go. There we go. Yeah. Ocean's on fire.
Yeah, and the upwelled stuff in the Bahamas and east of Florida. I mean, that's only recent, right? So drawing from that area, you were still up until recently drawing off a very warm hot plate.
It'd be interesting to just a little bit more of a research study, but the points come up a couple times about September being maybe most impacted by climate change, at least in terms of national CDDs, and then of course the comments about the oceans and stuff, and it seems like at least a hypothesis that that sort of lag relationship, the oceans heat up the most and kind of peak probably sometime in August or early September, somewhere around there, right? And then so maybe there's the sensible heating or whatever, the kind of impact that it's having on the low level temperatures, 2 meter temperatures like Jason had. Maybe it's having the greatest impact, or that's in part why we're seeing more of an impact near the end of summer versus early summer. Just a hypothesis, but it is something we can potentially test down the road.
Be interesting to look at dew points too, and if you
Yes.
take a look at that. I mean, the elevated mins and elevated dew points have been doing a lot of work.
That's a good point. Yeah. See, Michael, anything else on attribution, you think, before we move over?
Yeah, one last thing I wanted to add was this with regards to the CFS. I just did a quick check to see before we started to see if using the bias number from here for the CFS would have made it any better, and even with the +11 the bias correction, it's still only barely positive. It doesn't even break 30. So, and it's that's just kind of tying into. I noticed you added in as a question for this week, I think, as well as last week. Talking about the CFS. So I just figured I'd toss that in there. That even with the bias correction on this page, it still isn't exactly a particularly good forecast.
Hey, Michael, on that note, I totally forgot about this, but Luke LaBelle created a really cool graphic. Would you mind if I share my screen real quick? I'll show it and I'll give it back.
Go ahead.
All right. I think I have it up here. I think this is it. Yeah. So this is a work in progress, but this is Luke's working on improving our a system where participants can kind of test their formulas on the fly and get a better sense of what weighting schemes and stuff work better, this, that, and the other thing. But anyway, this is a chart he created. It's for this summer, so go starting back June 1st to near September 1st. The dates are based on initialized dates. So June 1st is the initialized date. And the time series here, the top dashed line, that's the 10-year normal. So, you see the curve where it peaks in July. And then the dotted is the 30-year. And then overlaid on top of that, you've got in black, you've got the observed, the ECMWF is blue, and in red, you've got the CFS. Sorry, I chuckled. But, so there's a couple interesting things that come out, right? One is, of course, the CFS, just consistently, being very too low, too cold, right? I just all summer long, this is something we've witnessed, but this is a nice sort of visualization of that. And then, of course, I've had the benefit of looking at this chart, but I'll just make one other comment. In terms of the ECMWF, so the blue, one of the things that I looked at, so obviously it's a little bit better, or it looks a little bit better than CFS, but then I looked at some of the big pattern shifts that we've had this summer, because my thought was, well, how's the ECMWF done during pattern shifts? And boy, at least visually speaking, the answer is not good. So here are the 2 or 3 examples that just stood out to me. So again, black is observation. So we had that period in that verified in later July, but these were the forecasts in early and mid-July, where we saw that period where we did get a little bit of a cooler, less hot period toward the end of July. And the ECMWF did not pick up on that, right? It was, if anything, going in the other direction. So ECMWF not helpful in identifying that at least period of less hot weather. Then you had another period here in August, early mid-August, where again, for at least a short period, we saw a cooler pattern verify, less hot. And again, the ECMWF, like a sore thumb there, stood out and said, no, it's going to remain hot. It was very much delayed in terms of picking up on that, and contemporaneously was not helpful. Then finally, we just talked about how September is turning into, one of the record warm month. Well, we saw the forecast in late August start to shift hotter, for periods verifying in September. The ECMWF again was arguably not only not helpful, but probably would have taken you in the wrong direction. The ECMWF was pointing at, something cooler, less hot. And of course, we know, again, what's verified here in September, a very warm, if not record period. So a couple just observations on my end. Turn it over to you guys for anything else.
It's interesting, the first little shift, I guess that's in June, where the previous peak right there goes up and then down, but all of the models saw that valley there in the temperature. You see, that's an interesting.
It's a good point. Yeah.
Forecast for everyone seems to be on something. There's still some biases there. At least the direction is captured.
Professor Decker's glass is half full kind of. Yeah, so, yeah, that's a good point, though. By hook or crook, it does seem to capture that. I don't know, Jason, do you see anything else there that worth noting?
I mean, not that I could speak with authority on looking just at the weighted degree days. The CFS has been a very disappointing platform this year, seemingly led astray multiple times by Central and Eastern Pacific warm SSTs, where it wants to either extend tropical forcing across the center part of the Pacific Basin, or whatever's in the Eastern Hemisphere coax it out too fast. And that seems to be the majority of the CFS downfall, anecdotally so far. I mean, just this recent week where we were lamenting its very, very poor performance. This was the week of the big eastern propagating mode coming across the Central Pacific again, and I think it latched onto that and tried more meridionally arcing wave trains to put more ridging in Western North America that just did not work. The convective forcing seemingly really didn't link up to the mid-latitude Pacific jet very much this time. And the negative VP just squirted through. We'll see that in a minute here in the 200 millibar VP hub molars.
Okay, and Michael, I'll turn it back to you, and I'm going to stop sharing my screen. I don't know, Michael's also, and this is for Jason's benefit, Michael's testing maybe some bias correction methods for the EC and CFS. I know, Michael, it's still a work in progress, so I don't want to put you in the spot, but Yeah, is there anything else that so far that you've seen in your research? Any other highlights in terms of trying to bias correct those inputs?
The only thing I can say is really that that graph you showed essentially is the same conclusion I came to. There's really like just using a flat bias correction for the euro is kind of difficult, I guess would be the word, since it does kind of flip flop between too warm and too cold.
Right.
So that's really the only thing I have to add to that.
Right. Yep.
All right. So unless anyone has any other comments, we can move on to the current week forecasts. Okay. So this week, I guess I'll start it off. I went with 60% teleconnections, 30% CPC, and 10% 10-year normal. So looking at the NAO, looks to be wanting to go positive. Generally speaking, looks like the longer range forecast, at least I believe this is GFS, has been relatively accurate recently, a little even on the positive side before that. So leaned positive with the NAO. The AO not too big of a factor yet, at least in my opinion, but still appears to be on the more positive side. And the PNA, this was an interesting forecast. That's quite a drop of, it looks like going almost 5-ish standard deviations down. So that was interesting. I had never seen something like that before, at least not with the PNA. So that seems to be negative, although it has been verifying very positive, at least on the positive side of the range recently. So maybe that won't work out, but it still seems to be, even accounting for taking off one standard deviation, does seem to still be negative. That agreed mainly with the idea of provided by the CPC, warmth in the southeast and south broadly with some cooler temperatures to the north, but these areas aren't really producing CVs at this point. So as such, I went with 18.4. I could even see it being in the low 20s, as Jason indicates, 21. I could easily see it getting to that. So that's my 2 cents here. Who would like to go next?
I guess I could go. So I always do the CPC forecast. So I'm basically trying to turn that map into another forecast for everyone to try to beat. And so as Michael alluded to, the areas of below normal don't really matter this time of the year. You can't have as negative CDDs. So the fact that the areas that are contributing to CDDs are all pretty much above normal, and in some cases significant probabilities above normal down in the southeast, I went 3/4 of a sigma of the climatology, or that's my qualitative interpretation of that map into a CDD forecast.
Okay, thank you, Dr. Decker. Who would like to come up to bat now?
I'll go next. So I kept factored in the same inputs that I usually do: the CPC trend and the 10-year normal. Basically, I actually switched up the percentages of the weighting scheme that I used. Last week, the 10-year normal its performance was not as strong. And if you look at what it's producing for value this week, it's not that much warmer than the 30-year. So based on what the CPC was showing and what the trend forecast was showing, that it was going to be much warmer, and what we've seen over the last couple of weeks anyway, the verifications being a lot warmer than anything. We've put less weight on the 10-year, even though its performance overall has been strong. But based on just the fact that September has been so warm, I'm just going with a hunch that it's going to continue to stay warm. So I picked a value of like 16 and a half, I believe. This forecast was more of a gut feeling than anything else.
All right, I can go here too. Jason, don't worry, we saved the best for last. So, yeah, so I'm input number one here. Yeah, so my first of all, my forecast formula didn't change significantly from last week, so that's the same formula I have. In terms of just a couple of the caveats to the forecast or data points that I maybe struggled with. On one hand, I feel like my number's too low, right? For some of the reasons that have already been discussed. I mean, looking at Jason's number and things like that too. And, I was looking at, obviously we've been in an extremely warm pattern. We talked about September and the 1 to 5, 6 to 10 day forecast. We don't have to pull them up, but the CDD numbers are also still extreme into the 6 to 10. I think according to Maxar's forecast, I think their 6 to 10 is something like 15 CDDs above the 10-year. If I read that correctly. So then I looked at my number for the 16 to 20, and it's like a couple CDDs above the 10-year. So I do think there's an argument for that. The reason I didn't do it is just a couple things, right? We've already talked about how the 10-year normal has been by far. I think I shouldn't say by far, but I think has been the most reliable, best performer for much of the summer. Beating the ECE, CFS, and most of the other inputs. So, again, that was my data point to say, why am I going to be so different this time? Also, there's the variability. We looked at the last map, and the map that I had up earlier that showed the time series, verification and all the model inputs. And one of the things you see there was, even when we had those heat spikes, right, they did break. Right, and I mean, I guess that's obvious, but it's not like they stayed at that extreme heat for 3 weeks in a row. And so, despite the fact that we see this extreme heat, I just don't have good confidence, or there's no data points that I can hang my hat on that says to me that it's necessarily going to continue for an extended period. And the final caveat to that is we're also moving into October. So we've talked a lot about how hot September is and how there's a historical precedence. Well, that's a little bit different for October. The only other things I want to bring up, and we kind of already touched on this, was, and this is a data point for the cooler side, is, we talked about although you look at the EC and CFS, and you kind of get a feeling of warm forever. We know that those models, in particular, I guess to pick on the ECMWF, which historically is a more reliable model, has not performed well with the pattern shifts, and including those cooler pattern shifts. So I also wanted to be very careful about overweighting, the idea that, hey, the ECMWF is showing it's going to stay warm, so, it's going to stay warm. We know a couple of those instances where we did see the big shift cooler this summer, it did not read it correctly. And the final data point I'll bring up in terms of my forecast and why not going warmer is the MJO. So I know the MJO's in what I think is mostly considered to be warmer phases right now, but in some of the MJO analytics that I looked at, phase 3 can be a much more volatile, variable pattern. And although, looking at some of these forecasts, it looks like phase 3 is an impossibility. Some of the statistical MJO models suggest that phase 3 could be more of a reality that we could move over, over the next 15, 20 days. And to me, that also adds some uncertainty, i.e. if we're in phase 3 versus phase 2, then historically the relationship is not as strong. So anyway, those are basically the foundation points of mine. I'll turn it over to Jason now. And Jason, before you get going, why don't you we're going to do like the mid Jeopardy kind of introduction. Why don't you give us I know you're a returning champion, but just a quick introduction, a little bit on your background.
Yeah. So I'm a Sooner, in case you haven't noticed by the background. This is my son's room, which I use as my meeting room. Work from home. Currently work for a weather technology company based in Boston called Climacell, but I'm in New Jersey. I'm in New Jersey because I was at a big commodities trading fund in Manhattan before it closed shop, making too much money in cryptocurrency. So I landed at Climacell, which I'm thoroughly enjoying. Working at Climacell to help them monetize weather information through asset protection, asset optimization, and advising commodities trading clients and utilities from day one to next season. My background, I was a severe weather guy at OU. Started at the National Severe Storms Laboratory as a sophomore. Worked all the way through grad school there, then went to SPC. Really thought I was done with my career because I absolutely loved severe weather, loved being in Norman, and thought I was on track to be a WCM somewhere in the plains, and I was just fine with that. And then a buddy of mine got a call to go work at an energy company, helping them do load forecasting and essentially shooting fish in a barrel in the early 2000s. It was an excellent way to monetize the science of meteorology. So I took a look at an energy job in 2002 and jumped out of the weather service track into the private sector, doing mostly short-term forecasting in support of power trading. And that quickly blossomed into medium range forecasting in support of term power trading, natural gas trading, some crude and products trading, and eventually some ag trading support. Recognized only a couple years in the energy industry that it's us against models, and you either have two ways to go there. You can spend a whole lot of money trying to make a better model, but then you're essentially going up against the army that is ECMWF, and I just don't think a couple of folks with a small resource budget are going to outdo ECMWF modeling capabilities over the long haul. So I felt the other angle was to try and throw better science at the forecast problem, and did a lot of research on what frameworks or methodologies would bear the best fruit, and landed on the Global Synoptic Dynamic Model from Ed Berry and Dr. Klaus Weichmann, two researchers within Esrel way back when. I formed a really close relationship with them, lasted a long time, ended up hiring them out of the government to come and work for us at Bank of America Commodities. That was a phenomenally fantastic time. I kind of think one of the pinnacles of private sector weather forecasting, using weather for profit. Tried to take a lot of those lessons and apply them through the rest of my career. So still see myself supporting commodities trading for a long time, especially natural gas, power, and ag. I think this is a good place to be, even with a whole lot of additional gas production. I still think I can have a decent career in the next 10 to 15 years doing this.
Great, thank you.
All right, now I'll talk about some forecast stuff.
Yeah, go for it.
All right. So Dave, I think you made some interesting points about leaking into MJO3 as a potential risk factor for going too warm with this particular 16 to 20 day forecast. However, you also made a really good point about the ECMWF weeklies not being able to pick up on pattern change very well. I do think each of those times had some kind of dynamical trigger or catalyst to suggest that there was an elevated risk of pattern change, just past the 11:15, sometime like that. I don't see much of a good catalyst right now, and I think we threw a lot at the system over this past week to 10 days without much response in the mid-latitude jet stream structure. So I'm pretty aggressive. I hope I have the warmest forecast. I think I do. And I actually started at 24 and pulled it down to 21. 24 would have been I think a record for the week. It's excessively courageous, in my opinion, to forecast records at a 16 to 20 day lead time. And I felt a 1.5 sigma on top of the 10-year. So 10-year already elevated, then going damn near 2 sigma on top of that. I felt that was plenty to send the message that I like warm. So my formula, so 50% of the view was kind of based on the foundation of a collaborative, calibrated multi-model ensemble of the ECMWF and CFS that we have with a another small research vendor group. It's proven to have very good performance, especially with probabilistic forecasts. It has very good reliability in the weeks 3, 4, and even week 5 lead times. It tends to shut the CFS up when it doesn't know what the hell it's talking about, and let the CFS talk a little bit whenever it's in its wheelhouse. That's what the calibration is really added to the mix to increase the value. And it's a full 20-year hindcast calibration at every grid point at every time step. So it's a pretty rigorous process. I found it to be pretty useful, pretty nice tool to use over the last 6 months since we've started the collaboration. The other half is Voodoo. It's my Voodoo. So in my interpretation of the combination of what this negative AAM background state that we can't get out of, and related to that negative AAM state, these flat circuits in the bottom half of GWO phase space, really spending a lot of residence time in phases 2 and 3. The convective forcing signal via the MJO RMMs, it looks like there's been a really nice eastward propagating signal every 30 to 40 days for many months going on, and it reemerged here over the last 7 to 10 days with a really nice signal crossing the Pacific and Atlantic basins. I'll show that in the Hugmullers in just a second. And now it kind of looks like there's going to be some stall potentially related to the SST anomalies in RMM phases 1 and 2. I do consider a leakage to 3 a cooler risk factor, like Dave mentioned. I think that's worth highlighting. However, I think we just gave a really solid try to get AAM up out of the gutter and couldn't do it. And until AAM gets up out of something higher than -1.5 sigma, then I'm fine building cold air in Canada and not putting it in the east or south. And if we're not going to put it in the east or south with those neighborhood SSTs that we saw, and I'll just go ahead and start with that in another plot. With all of this warmth across the neighborhood of the U.S. to the south and southeast, and I even this cool patch really doesn't bother me from the upwelled stuff. It's shallow upwelling. The longer trajectories would come out of the bath water that's in the Caribbean. So I don't see us having much of a northward or northwesterly trajectory of source region air masses into, say, Nashville, Atlanta, Richmond, Virginia, or Texas very frequently or in durable fashion. And thus, I think it makes a whole lot of sense to maintain definitely a warmer than normal skew. But then there are very few prisoners taken when the pattern goes warm with these nearby SSTs elevating minimums, elevating dew points. So not only can high temperatures do some of the anomalous work, you just don't fall off much at night like you used to. Now the Northeast, Philly northward could be a different ball game. There is a nice negative NAO projection period coming up that could linger a little while longer. I don't necessarily disagree about the NAO going positive in our target period for the 16 to 20, but there's sometimes a difference between the actual calculated projection and what you see in the 500 millibar height anoms, or what can happen with the 850 temp anoms and the trajectory of low-level air masses. It kind of looks like when you look at the back of the 1115 off of the Euro ensemble on the global projection, there's still a negative tilted longish wave trough here from north central Canada through eastern Canada and the northern Gulf, and some suggestion of cut off positive height anomalies left to spin up there over northeastern Greenland and north of Iceland. So this is the kind of situation that can support some backdoor cooling late 11 to 15 into the 16 to 20. But I also think at times that can actually enhance some of the compressional heating at the apex and the northeast flank of subtropical ridging, which would be over the Ohio Valley, over the southern mid-Atlantic and southeast. And you can actually enhance the warmth there. So sacrificing Boston and New York City, paltry CDD levels from Climo at this stage to enhance some still meaningfully decent CDD levels from a climate perspective in the Ohio Valley and Southeast. I'll take that trade-off and call that actually a warmer influence on the CDD total. Okay, so large scale, starting with large scale SSTs, I talked about the neighborhood, looking more at the large scale ocean basins, Cool Tongue here in the Eastern Tropical Pacific. At some point, this Central Tropical Pacific and Northwestern Tropical Pacific warmth, I think, will matter. I believe we should see some enhanced convection over those areas before we get to December. I just don't think it's going to come to the rescue of October yet. I had some thoughts about the Indian subcontinent and Southeast Asian monsoon systems withdrawing in the latter part of September, allowing these SSTs to be more attractive as anomalous convective supporting regions. That didn't work. The Indian subcontinent and Southeast Asian monsoon systems have hung on with great vigor through September. So, and I think that's contributed to the overall low AAM base state, and also probably thwarted the connection to the mid-latitude jet that the recent, where's my guy, that this recent eastward propagating mode tried to show. Is it this one? Yeah, this, okay, here we go. So here's the 200 millibar velocity potential hub molar, and above this line, these are all observations. Below that line, I've chosen the Euro ensemble mean forecast. Really nice eastern propagating mode that went into beast mode here over the central and eastern Pacific back through the middle third of September. And AM actually fell during that period. And that told me all I need to know about the balance of September. I mean, when we got to about the 10th to 12th and there was no substantial uptick in AM, you could forget substantial cooling for September. And that's when that big inflection point, we turned around and went from under, like a number 5 or number 8 rank in CDDs to blowing the doors off of the last year record. And now you can see in the forecast, there's this suggestion to stall here in East Africa, Western Indian Ocean, and actually nosing its way back towards the western half of the Indian subcontinent. This, to me, says maintain negative AAM anomalies all the way through at least the first half of October, if not longer. There's a slight suggestion that there'll be maybe a low amplitude, fast-moving Kelvin wave that can try and sneak eastward out of this. But I don't think it's going to be very effective in changing eddy tilts over the Pacific Basin, and thus probably not very effective in getting AAM out of the gutter. Which brings me to, let's look at the AAM plots. So let's go here. Bang. And look here historically. I mean, we've probed the depths of the AAM. I think we've touched some record negative territory here during September. And if we look at some of the ensemble plots, there's this flat circuit in the bottom half of GWO phase space where AM comes up out of a 3 sigma negative anomaly, but and heads right back lower. So -2 to -3 sigma. That's something that I'm not going to go against the grain, and I believe I mentioned that in my discussion. So basically, ride the negative AM signal until you get bucked off, and or until the subtropical ridging over the southeastern U.S., the Gulf, the Southwest Atlantic Basin is pretty clearly eradicated. And I believe these are obviously dynamically connected. So let's see, with time winding a little lower, I'm really leveraging the negative AM and this RMM phase 2-3 forecast, and I kind of wanted to show that as well. Just an RMM phase space, and use some rolling 2-week bias corrected methodologies to plot the ECMWF and GFS ensemble members. Really good, even though it's a relatively noisy, bird's nest of a plot. All of the members are over here in phase 1 and 2, with exception of like a handful of weird GFS ensemble members. So, extrapolating the end of the 11-15 RMM projection, I think we're pretty safely going to be in phases 1 and 2 for the 16 to 20. And OCT phase 1, modulated by a negative AM background state, is a big warm period, even with some ridging over northwest North America. Notice it actually catches some of the positive, or at least neutral positive tendency in the NAO here as well. This doesn't improve any when you go to phase 2 either. But to drive home Dave's concern, which is a cool risk of mine, you can see the composites, even though there's only 18 events included in the MgO3 low AAM modulated state, it's definitely a cooler risk. So that's something to watch. The other thing that I incorporated quite a bit, I wanted to show you the GWO phase space, being a GSDM disciple. Flat circuits nicely and safely displaced into the far low side of phase space here. And so when we look at October GWO 2 and 3, pretty solid negative PNA in phase 2, widespread warmth in phase 3, and you got to think these kind of negative height anomalies are more tropical related than they are bringing any kind of cooler air mass into the picture. So this says stay warm across the southern, at least third of the nation, southeastern third, maybe the southeastern half or more. With that kind of large-scale pattern, I think one has to look in the Southwest Atlantic Basin, Caribbean, and Gulf for potential tropical cyclone issues. So I actually think there's an elevated over CLIMO tropical cyclone risk in the Caribbean and Gulf during this period as well. I think that's good for now, given the time constraints.
Okay. Thanks, Jason. That was really, really in depth. Does anyone have any questions for Jason? He's got about 8-ish minutes before he has to go. All right. Well, I'll actually have a question. So you mentioned the GLAM. Does it change from month to month? So if you have if we kept the negative GLAM going through December, is that okay? So that does change.
Yeah, it's seasonally dependent. It's essentially recomputed composites on a 60-day centered window. So essentially plus or minus a month around today, and you roll it forward. Okay. Moving window.
Thanks.
And Jason, we had another question too. I know we don't have a lot of time, but could you give a brief background into the GWO and how you use it in conjunction with the MgO in your forecast process?
Yes. So let's go back and share here. All right, let's go to AM. All right, the basic tenet of the global synoptic dynamic model is built around the notion of the interaction between multiple spatial scales of physical processes that have multiple time scales. So there are fast-acting processes which can feed energy or rob energy from slower-acting processes. There are small-scale processes that can feed or sap energy from larger scale, lower frequency processes. The global synoptic dynamic model is built on the AAM budget, the total global integrated AAM budget, and essentially does a pretty solid job at trying to capture the interaction of these processes across the various time and spatial scales. Ed Berry and Dr. Klaus Weichmann recognize that you tend to have large mid-latitude wave train changes and regime changes over the large continents when there are large changes in global atmospheric angular momentum. And so now tracking the global atmospheric angular momentum background anomaly against its tendency tends to highlight these periods where there's a lot of stuff happening, where there's a lot of things changing, where there's a lot of exchanges of heat and momentum in a meridional fashion that could either build blocking or tear down blocking or change eddy tilts to flux momentum poleward and heat equatorward. So when we track the overall AAM anomaly, the AAM anomaly time series and its first derivative essentially both tell us something interesting. So the background anomaly tell us the overall regime, generally a lower than a negative AAM background state tends to have more La Nina-esque type behavior where you have a lot of positively tilted pattern features in the mid-latitude jet stream, which tend to flux momentum poleward and build and maintain a lot of mid-latitude ridges in the central and eastern parts of the large continents. And that all is different when you have a generally positive anomalous AAM background state, where you tend to have more negative tilted pattern features in the mid-latitude jet stream. More westerly momentum is fluxed from the pole towards the equator. You tend to extend continental jets across ocean basins and have cyclonic wrap-ups in their exhaust regions, which tend to build ridges to their north and downstream troughs. More positive PNA, negative EPO type structures. And this has been a really good way that I have found to first try and attribute the current state of the pattern and its recent evolution to various physical processes that are responsible for getting us here. And then you can try and extract some predictability by forward extrapolating those processes and taking typical composite results to sanity check models. And the sanity check of models is actually a really valuable component. None of the correlations we use in this science are perfect 1.0s. There's always exceptions to all the rules, but if a model is not dynamically consistent with itself, then to raise a red flag and either discount it or allow for other ulterior scenario evolutions. Don't get overly confident. So when you typically have these big excursions, like a 3 sigma departure in AAM space, you're usually going to have a pretty solid, predictable response. And indeed, this has happened here through the latter part of summer, where big negative AAM has indeed fueled more frequent and stronger and northward extending subtropical ridges through the mid-latitudes, and done a fine job at foretelling and explaining why September's been hellaciously warm.
All right, so we're about out of time here for Jason. Unless anyone has any quick questions, I'll send him off a couple of minutes early.
Yeah, I thought that was a great description of the GWO. That was really helpful. It's nice that we're in a situation actually where there's also like an application of that GSDM.
Indeed, and a somewhat interesting one at that, where we had this really strong eastern propagating mode crossing the Pacific, which tends to try and perk AM up. And when the GSDM components themselves caught the fact that AM was not going to go higher and indeed was going to go lower, I think that was a very, very telling pivotal point in the September forecast.
Great. Michael, I think we're all good on our end over here.
Okay, so if Sounds like no one has any other questions, so I guess we'll stop a couple of minutes early today. Thanks, Jason. Discussion was great, very informative. Hope to have you back soon. Thanks everyone else for contributing, and yeah, have a good day, everyone.
Thanks for having me, guys. Have a good one.
All right, thanks. Thanks, Jason. Thanks, guys.